गुड आफ्टरनून टू ऑल ऑफ यू। हाउ आर यू? कैसे चल रही है आप लोगों की एग्जाम की तैयारी? हम्म? आप लोगों की एग्जाम है, टाइम टेबल मिला है आप लोगों को? टेल मी, हैव यू गॉट टाइम टेबल और नॉट? कब है हम लोगों का पेपर? पेपर 2 इनऑर्गेनिक केमिस्ट्री 24th को है ना? करेक्ट, एम आई राइट? बोलो, टाइम टेबल देखा है क्या आप लोगों ने? कब है हम लोगों का पेपर 2? विक्रम, सुप्रिया, विश्वजीत, 24th का, 4th को है शायद, ट्यूसडे। करेक्ट। Do you know the pattern of your exam? Yes, Vishwajit is saying 24th. Correct. आप लोगों को पैटर्न पता है क्या? पैटर्न इज सिमिलर टू आवर ऑनलाइन टेस्ट। हम लोगों ने जो ऑनलाइन टेस्ट लिया है, आप लोगों के दो टेस्ट हम लोगों ने शायद लिए, दैट इज बेस्ड ऑन चैप्टर नंबर 1 एंड चैप्टर नंबर 2। तो सेम पैटर्न विल बी देयर, ठीक है? And let me tell you one thing, that we will also conduct online examination for chapter number 3, that is CFT, crystal field stabilization. That test be is on I think we will take it tomorrow after my lecture. Today we will finish this chapter. Only two small points are left. One point is application of CFT to the octahedaal complexes, that we will see now, and limitation of valence bond theory is left. So it will require hardly 30 to 40 minutes. Okay, so today we will finish this chapter, and in the morning I have sent you the notes also for this chapter, that is chapter number 3. Okay, please see it on Google Classroom. I have sent you the PDF notes. And tomorrow, after the lecture, tomorrow we will start our last chapter, that is chapter number 4, MOT, molecular orbital theory. We will start tomorrow. We will start with some introductory part, and we will see the assumptions of molecular orbital theory. These 2 points we will see. These 2 points we will hardly require 15 to 20 minutes. So tomorrow's lecture will be for only 15 to 20 minutes, and after the lecture we will conduct examination, which is based on chapter number 3, that is CFT, crystal field stabilization energy. Yes or no? अंडरस्टूड आप लोग? सो द पैटर्न फॉर योर इंटरनल एग्जामिनेशन, जो कि आप लोगों की होने वाली है 24th ट्यूसडे, देयर विल बी 10 मल्टीपल चॉइस क्वेश्चन, 5 क्वेश्चन फ्रॉम माय साइड एंड 5 क्वेश्चन फ्रॉम मैडम साइड विल बी देयर. टोटल मार्क्स इज फॉर 10 मार्क्स. देन द टोटल टाइम फॉर दिस टेस्ट विल बी 20 मिनट्स, आई थिंक. करेक्ट, 20 मिनट्स ही है ना? ठीक है. ओके, मल्टीपल चॉइस क्वेश्चन होंगे, फिल इन द ब्लैंक्स, चूज द करेक्ट और ट्रू और फॉल्स काइंड ऑफ क्वेश्चंस विल बी देयर. ठीक है, अंडरस्टूड? सो इफ यू हैव अंडरस्टूड द इंस्ट्रक्शंस व्हिच आई वांटेड टू गिव यू, देन वी विल स्टार्ट द टुडेज लेक्चर. ठीक है, तो मुझे बोलो, कैन आई स्टार्ट टुडेज लेक्चर? यस और नो? कैन आई स्टार्ट द लेक्चर? What we were talking about in the last lecture, I think we were talking about the John Taylor distortion or tetragonal distortion. ठीक है? So क्या देखा था हम लोगों ने while discussing the John Taylor distortion? If octahedaal complex is there, in that octahedaal complexes what happens? Z out case will be there. What is the portion for the internal Sarman? She is asking about the portion or syllabus जो हम लोगों ने चैप्टर नंबर 3 तक रखेंगे. ठीक है, चैप्टर नंबर 1, चैप्टर नंबर 2 एंड चैप्टर नंबर 3. सो 3 चैप्टर्स विल बी देयर फॉर योर एग्जामिनेशन. 3 चैप्टर्स रहेंगे आप लोगों के फॉर योर इंटरनल एग्जामिनेशन. चैप्टर नंबर 1 क्या देखा था हम लोगों ने? इंट्रोडक्शन टू कोऑर्डिनेशन केमिस्ट्री. चैप्टर नंबर 2 वाज वैलेंस बॉन्ड थ्योरी. चैप्टर नंबर 3 इज क्रिस्टल फील्ड थ्योरी, दैट इज CFT. ठीक है, सो दिस 3 चैप्टर्स विल बी देयर फॉर योर एग्जामिनेशन. ठीक है, ओके, तो हम लोग क्या देख रहे थे, हम लोग देख रहे थे जॉन टेलर डिस्टॉर्शन. इफ octahedral complex is there, there are two cases. If axial bonds they will get compressed, then it is called as a Z in case, or it is also called as axial compression, that you know very well. And if axial bond they will get elongated, then it is called as a Z out case, or axial elongation is there. ठीक है. Result, when we will get result of internal examination, Chetan is saying that I don't know. Result of examination I don't know. It will be discussed by college and our head also, so I don't know about that. Okay. So what happens in that axial elongation? So axial bond they will get elongated, and at one point what happens, at one point they will get elongate, and at one point they will get completely detached from your central metal atom. They will get completely detached from your central metal atom. So what happens once they get removed? So there will be reduction in your coordination number. Coordination number initially it was 6. It was 6. After the removal of two axial ligands, so coordination number will becomes 4. And at the same times geometry also will get changed. At the same time geometry also will get changed. Initially geometry was octahedral geometry, because your coordination number 6. So after John Taylor distortion, two axial bonds they will get removed, they will get detached from your metal, and there will be reduction in coordination number takes place. So coordination number decreases from 6 to 4, and geometry changes from octahedral geometry to the square planar geometry. So this is the formation of square planar complexes. So what is the splitting of 5d orbital into the square planar geometry, that we will see today. Okay, how it will get split, what is the relation between delta octahedral and delta sp, that is square planar, that we will see today. Okay, so can I start lecture now? ठीक है. So ठीक है. So this is your lecture number 7 of crystal field theory. This is your lecture number 7 of crystal field theory. ठीक है. So today we will see the application of CFT, that is crystal field theory, to the octahedral complexes. No octahedral complexes नहीं है, ये तो वही कॉपी पेस्ट किया है मैंने. तो ये क्या हो जाएगा, स्क्वायर प्लेनर कॉम्प्लेक्सेस. ये हो जाएगा स्क्वायर planar complexes. So today we will see the application of CFT, or assumptions, whatever the assumptions we have seen, we will apply that assumptions to the square planar complexes. ठीक है. तो क्या है फर्स्ट पॉइंट, अकॉर्डिंग टू द जॉन टेलर डिस्टॉर्शन, कि मैंने आप लोगों को अभी अभी बोला है, अकॉर्डिंग टू द जॉन टेलर डिस्टॉर्शन इलोंगेशन ऑफ लिगेंड अलोंग द z एक्सिस टेक्स प्लेस. ये हम लोगों ने अभी देखा है और लास्ट लेक्चर में देखा है. अकॉर्डिंग टू द जॉन टेलर डिस्टॉर्शन व्हाट हैपेंस, the ligands which are along the z axis, or which are along the axial position, they will get elongated, and at one point what happens, they will get detached, completely removed from the central metal atom. Okay, in practice, now in practice what happens, in practice these ligands along the z axis are removed. ये मैंने आप लोगों को बोला है. In practice the ligands along the z axis they will get removed, and as a result of this, what happened, coordination number, Cn is what, coordination number. As a result of this, coordination number and geometry changes from 6 to 7. Coordination number changes from 6 to 4, and geometry changes from octahedral to square planar. ठीक है. So due to the joint Taylor distortion, elongation of axial bond takes place, and at one point what happens, that axial ligand they will get completely removed from the central metal atom, and there is change in coordination number or change in geometry of that complexes takes place. Coordination number 6 to 4 हो जाएगा and geometry octahedral to the square planar हो जाएगी. ठीक है. Then during the formation of square planar complex, so that we have seen how square planar complexes they will get forms. So during this formation of square planar complexes, what happens during, see here, listen carefully, during the formation of square planar complexes, the degeneracy the degeneracy of EG orbital get removed. तो आप लोगों को पता है EG orbital, that is dx square minus y square and dz square, these two orbitals they are called as EG orbital because they are doubly degenerate orbital. ठीक है. So during the square planar complexes, तो जब square planar complex form हो जाता है, during that time what happens, degeneracy of EG orbital will get removed. So degeneracy of EG orbital will get removed means what happens, the initially both these two orbital they are in same energy level, and during this square planar complexes what happens, their energy will get changed. One orbital will get higher in energy and another orbital will get lower in energy. So it is called as a removal of degeneracy. So during the square planar complex, degeneracy of each orbital they will get removed. दोनों के दोनों जो पहले सेम एनर्जी लेवल पे थे, उसकी एनर्जी लेवल क्या हो जाएगी, चेंज हो जाएगी. और कौन ऊपर हो जाएगा, कौन नीचे हो जाएगा. नेक्स्ट सेंटेंस पूछो, नेक्स्ट लाइन रीड करो. द dx स्क्वायर ऑर्बिटल गोज इनटू लोअर इन एनर्जी. dx स्क्वायर ऑर्बिटल जो है वो क्या होता है, वो लोअर इन एनर्जी हो जाता है. एंड dx स्क्वायर माइनस y स्क्वायर ऑर्बिटल गोज हायर इन एनर्जी. क्या हो जाता है, dx स्क्वायर orbital जो है that orbital will go in lower in energy while dx square minus y square orbital goes into higher in energy. See this figure. So initially these two orbitals they are EG orbital. These two orbitals they are EG orbital. ठीक है. ये तो we know one orbital is dx square minus y square and this orbital is sorry, not dx, it is dz square. It is dz square and another orbital is dz square. So during the square planar complexes, the degeneracy of these orbital will get removed and dz square orbital will go lower in energy and dx square minus y square orbital will go higher in energy. So this happens to the EG orbital while formation of square planar complex. ठीक है. तो आप लोगों को अभी पता चल गया कि EG orbitals की क्या हो जाती है, degeneracy remove हो जाती है. Now what about the T2G orbital? T2G orbitals के साथ क्या होता है? See your on your screen. At the same time, the degeneracy of T2G orbital also get removed. Same result होता है जो कि EG orbital में हुआ. EG orbital में क्या हुआ था? Degeneracy remove हो गई थी. And in case of T2G orbital also, the degeneracy of 3 T2G orbital will get removed. इसकी भी क्या हो जाती है, डिजेनरेसी रिमूव हो जाती है. मींस इनिशियली 3 T2G orbitals they were in same energy level. After or during the square planar complexes, the energy of this 3 T2G orbital will get removed. Which 3 T2G orbital, dx y, dx z and dy z orbital. These three orbital they are called as T2 orbitals and they will get placed in different energy level. So कौन सा ऑर्बिटल ऊपर जाता है, कौन सा नीचे जाता है, उसके लिए हम लोगों को नेक्स्ट लाइन केयरफुली पढ़नी होगी. क्या होता है, द dx z एंड dy z ऑर्बिटल गोज इनटू लोअर इन एनर्जी. जो dx z एंड dy z ऑर्बिटल्स होते हैं ना, वो क्या हो जाते हैं, लोअर इन एनर्जी हो जाते हैं. एंड dxy ऑर्बिटल गोज हायर इन एनर्जी. सो सेम ट्रीटमेंट यही पे भी है. क्या होता है, एट द सेम टाइम degeneration of T2G orbital also get removed and the dxz and dyz orbital goes in lower in energy level and dxy orbital goes in higher in energy level. ठीक है. Now see the figure. Sorry, ये लाइन ड्रॉ करना भूल गया मैं. ठीक है. So this is your T2G orbital in octahedral field. This is your T2G orbital in octahedral field. ठीक है. Now what happens, ये जो है ना, ठीक है, ये जो है ना, ये ऑर्बिटल्स यहाँ पे नहीं है, ठीक है। लेट मी डू वन थिंग, लेट मी डू वन थिंग, ठीक है। Now read this one more time. At the same time, the degeneracy of T2G orbital also get removed, and the dxz and dyz orbital goes into lower energy, and dx orbital will go in higher energy. See the figure now. See the figure here. Here T2G orbital, it is in this T2G orbital, it is in octahedral geometry, you know that. And what happens, the dxz, see here, dxz and dyz orbitals goes lower in energy. These two orbitals, they will go into lower energy level, and dxy orbital, they will go higher in energy level during the formation of square planar complexes, during the formation of square planar complexes, ठीक है, समझ में आया। Now we will see the splitting of, we will see the splitting of 5D orbitals into square planar geometry। क्या देखेंगे हम लोग देखेंगे कि स्प्लिटिंग ऑफ 5D ऑर्बिटल्स इन स्क्वायर प्लेनर कॉम्प्लेक्सेस में कैसे होती है, ठीक है। ओके, सी हियर आप लोगों के स्क्रीन पे द स्प्लिटिंग ऑफ d orbital in square planar geometry, splitting of d orbital in square planar geometry। now see the diagram carefully, now see the diagram carefully। here 5D orbital, यहाँ पे जो है 1 2 3 4 5, these 5D orbitals, they are in free metal ion। ये किसमें, ये free metal ion में, ये you know that। and after the octahedral geometry, in octahedral geometry what happens, T2G orbital, they will go in lower energy level, and EG orbital, they will go in higher in energy, that you know very well। and this gap between T2G orbitals here, see here, this gap between T2G orbitals and EG orbital, it is denoted by 10 dq, or it is called as a del T, del O, sorry, it is denoted as a del O, the gap between T2G and EG। so this is the splitting T2G orbital and it is EG orbital। so this is the splitting, ये जो दिख रहा है ना आप लोगों को, this is the splitting of 5D orbital in octahedral field। now we have seen in square planar complex, here it is now in case of square planar, in case of square planar, in square planar complexes what happens, the degeneracy of T2G orbital, they get removed, and out of these 3 T2G orbital, dxz and dyz orbital, they will go into lower energy level, see here it is in lower energy level, and dxy orbital, it go into higher energy level, it goes into higher energy level। so this happens with T2G orbital। now again EG orbital के साथ भी क्या हो जाता है, सेम हो जाता है, the degeneration of EG orbital will get removed, and out of these two EG orbital, dz square orbital will go lower in energy level, will go lower in energy, and dx square minus y square orbital will go higher in energy level, it will go higher in energy level। now here the energy level of dz square orbital, which is from EG set, or which is from EG energy level, it is lower than dxy, please remember this, it is lower from the dxy। so lowest energy orbital is 2 orbital, that is T2G orbital, dxz and dyz। then कौन सा आता है EG orbital से, that is dz square, then again T2G orbital, dxy, and highest energy orbital is T2G orbital, EG orbital, that is dx square minus y square। so this is the splitting of 5D orbitals into square planar complexes, this is the splitting of 5D orbital into the square planar complexes or square planar geometry। now here the gap between dxy, see here this is dxy orbital, and this is dx square minus y square orbital. The gap between dxy and dx square minus y square orbital, it is called as a crystal field splitting energy of square planar complexes. It is called as a square planar splitting energy. It is called as square planar splitting energy. It is denoted by 10 dq or del sp. It is denoted by 10 dq or del sp. In case of octahedaal, the gap between T2J and EG orbital, it is called as a del O. In case of square planar complexes, the gap between dxy and dx square minus y square orbital, this gap is called as del sp. This gap is called as del sp. Please remember this. This is very important. The gap between dxy, which is T2J orbital, and dx square minus y square, which is EG orbital, that gap is called as a 10 dq, or it is denoted as a del sp. Why sp? Because it is a square planar complex. Why sp? Because it is square planar complex, or it is a square planar geometry. Okay? Understood the splitting of 5d orbital into square planar complex or square planar geometry? समझ ली कहीं? Tell me. And the difference between dxy and dx square minus y square is called as square planar splitting energy. It is called as square planar splitting energy. This difference between dxy and dx square minus y square orbital is called as a square planar splitting energy. Okay. Now the energy of dxz and dyz. Now here Sonal is saying yes sir. Okay. Now please see here the energy of this to this energy. The energy of dxz and dxy. This energy is 0.15. This energy is 0.15. dxy and dxz. This energy is 0.15. Then dz square energy from this to this. From this to this energy is 0.43. This energy is 0.43. And from this to this, now this to this dxy, this energy is dxy, this energy is 0.23. कितनी हो? 0.23. And this gap, that means this energy dxy and dx square minus y square, this energy is 1.22. This energy is 1.22. Okay, got it? Got the splitting of 5d orbital in square planar complexes? All of you have understood this? Okay, then we will see the next point. क्या है next point? Which is very important. Please write down this point. ये point आप लोग लिख के लो. The value of del sp. See here, the value of del sp is greater than the value of del 0. The value of del sp is greater than the value of del 0. It has been found that, the value of del sp is about 1.3 times greater than del 0. The value of del sp is about 1.3 times greater than del 0. That means the value or the magnitude of del sp is always greater than the del o, or the gap between, or the value of 10 dq in case of sp is about 1.3 times greater than the value of 10 dq in case of del o. Okay, understood this? Okay, then we will see the Nephelauxetic effect and Nephelauxetic series. This is also one more important effect or one more important series. हम लोगों ने पहले भी एक series देखी थी, that is called as a spectrochemical series. Yes or no? देखी थी कि नहीं हम लोगों ने spectrochemical series? Tell me. We have seen spectrochemical series. ठीक है? So this is also one effect is there, that is called as a Nephelauxetic effect, and according to this effect, ligands are arranged, and that arrangement of ligand is called as a series. That is called as a series, and name of that series, it is called as a Nephelauxetic series. This Nephelauxetic, please remember, it is It is not. It is not a name of scientist. Huh? It is a Greek word. Nephelauxetic means it is not a name of scientist. It is a Greek word. So what is the meaning of this Nephelauxetic or that Greek word? Nephelauxetic is a Greek word. See here, Nephelauxetic is a Greek word, and the meaning of this Nephelauxetic word is cloud expanding. The meaning of this Nephelauxetic, that is Greek word, it is a cloud expanding. So here expansion of cloud takes place. Here expansion of cloud takes place due to the effect of ligand. Due to the effect of ligand. Now यहाँ तो cloud expand हो जाता है. किसका cloud expand हो जाता है यहाँ पे? Can anybody guess? Cloud expanding is very good, but किसका cloud? Can anybody guess? Due to the nature of ligand or effect of ligand, the cloud is get expand. Cloud is get expand. Now किसका cloud expand हो जाता होगा? Can anybody guess? किसी को है idea? Tell me. If anybody has idea, d electron. Very good. किसका cloud expand हो जाता है? Here we are talking about or we are dealing about the electrons only. किसके electrons देख ले? तो d electron, d orbitals के electron देख ले. d orbital electrons of the central metal atom. So these due to the effect of nature or effect of ligand or nature of ligand, the expansion of d electron cloud takes place. Expansion of d electrons cloud takes place. This effect is called as a Nephelauxetic effect. This effect is called as a Nephelauxetic effect, and according to this effect, the ligands are arranged with increasing ability, with increasing capability of d electron cloud expansion. That series is called as a Nephelauxetic series. That series is called as Nephelauxetic series. So we will see first what is Nephelauxetic effect. First we will see what is Nephelauxetic series. See the definition. Write down this definition, which is very important. It is always asked for 2 marks in the examination, university examination. It is always asked for 2 marks. What is Nephelauxetic effect or what is Nephelauxetic series? Okay, so you have to write the definition. So क्या है definition? Listen carefully. The definition of Nephelauxetic effect: the effect of ligand in expanding d electron cloud of the central metal atom. The effect of ligand in expanding d orbital electron cloud of the CMA, that is central metal atom, that effect is called as a Nephelauxetic effect. That effect is called as Nephelauxetic effect. Okay, so this is the definition of Nephelauxetic effect. Write down this definition, then we will see the Nephelauxetic series. What is that series? किसको कहते हैं series? ठीक है. So this Nephelauxetic series means what? The series in which ligands can be arranged in order of their increasing d orbital electron cloud expansion is called as a Nephelauxetic series. Is called as Nephelauxetic series. The series in which ligands are arranged or ligands can be arranged in the order of increasing d electron cloud expansion ability. In the order of increasing d electron cloud expansion ability, that series is called as a Nephelauxetic series. And see the ligands, see the series of ligands. So very lower or lowest or smallest ability of d electron cloud expansion is of fluorine. किसकी है? सबसे lowest तो fluoride की है. Fluoride ligand which does not expand the d electrons to the greater extent, while I minus, that is iodide. See, both are halogens. Fluoride minus is also halide and I minus is also halide, but the difference in size of their fluoride minus has very small size, iodine has a bigger size. So due to the size effect here, the d electron cloud expansion ability of iodide is more than the fluoride ion. So fluoride is there at lowest position, then water, ammonia, oxalato, ethylenediamine, NCS, chloride और cyanide की almost same ही होती है, then bromide and then iodide. So this series is called as a Nephelauxetic series. This series is called as Nephelauxetic series. This series you have to remember. ठीक है. So this is one more important point, very small point is that is Nephelauxetic effect or Nephelauxetic series. It is generally asked for 2 marks. Write down Nephelauxetic effect and Nephelauxetic series. So you have to write the definition. First you have to write the meaning of that Nephelauxetic word. So you have to write Nephelauxetic is a Greek word and the meaning of this Greek word is cloud expanding. Then you have to write the definition of Nephelauxetic effect. Then you have to write the definition of Nephelauxetic series, and then lastly you have to write the series. Then you will get the 2 marks. Then only you will get 2 marks. Okay. Okay. Then the last topic we will see the limitation of CFT. Last time we will see the limitation of CFT. So first limitation of CFT आपके screen पे है. CFT considers only d orbital of the central metal ion and it does not considers the other orbitals such as s and p. So this is the major limitation of CFT. आप लोगों ने वैलेंस बॉन्ड थ्योरी में देखा होगा. वैलेंस बॉन्ड थ्योरी considers the s, p and d orbital of the central metal ion, but CFT does not considers the s and p orbital of the central metal ion. It only considers the d orbital of the central metal ion. It only talks about the splitting of d orbitals of the central metal atom. But what happens to the s and p orbital, that cannot be explained by the CFT. CFT क्या एक्सप्लेन करती है कि d ऑर्बिटल्स के बारे में एक्सप्लेन करती है, लेकिन अगर लिगैंड अप्रोच हो रहे हैं, जैसे कि d ऑर्बिटल में इलेक्ट्रॉन है, वैसे s पे भी इलेक्ट्रॉन्स है सेंट्रल मेटल एटम के, p में भी इलेक्ट्रॉन्स है, तो उसको भी s and p ऑर्बिटल के इलेक्ट्रॉन्स को भी कुछ इफेक्ट होता होगा. दैट इफेक्ट or that influence is not discussed by CFT. CFT only considers the splitting of d orbital. ठीक है. So this is the first and major limitation of CFT. Then second limitation is, you please write down limitations of CFT. You please write down. ये भी 2 to 4 मार्क के लिए एग्जाम में पूछते हैं लोग. ठीक है. So second limitation of CFT. CFT considers ligand as a point charges. ये हम लोगों ने पहले देखा है. CFT considers the ligand as a point charges, and these assumptions, कौन सा assumptions, कि ligands are treated as a point charges. This is one of the assumptions of CFT, and these assumptions does not represent actual situation of the central metal ion in the field of ligand. तो क्या होता है, this assumption does not represent the actual situation of metal atom ion in the field of ligand. ठीक है. This is the second assumption. Then third assumption is, CFT does not consider the possibility of covalent bonding. There are many properties which cannot be explained without the covalent bond. So according to the CFT, complexes forms only ionic bond. According to the CFT, हम लोगों ने पहले ही देखा है while discussing the assumptions of CFT. So according to that assumptions of CFT, the bond formed between metal atom and ligand is purely ionic and it is not a covalent bond. So CFT does not consider the formation or possibility of covalent bonding, but there are so many properties which is based on covalent bonding. We cannot explain that properties without considering the covalent bonding. ठीक है. So advanced theory आ गई है इसके ऊपर भी, that is called as a LFT. It is called as a ligand field theory, which considers covalent as well as ionic bonding, but CFT does not consider the covalent bonding. ठीक है. So this is the third limitation of CFT. Then fourth limitation is, CFT does not tells about pi bond formation. आप लोगों ने देखा होगा, CFT does not talk about the formation of pi bond. लेकिन VBT में हम लोगों ने देखा था there is possibility of pi bond formation. ठीक है. But CFT does not tells or does not talk about the formation of pi bond. But in practice or in actual, what happens, double bond, that means pi bond is present in many compounds. We have seen when the ligand which contains a pi bond, then that ligand can form a pi bond, but CFT does not considers the formation of pi bond. This is the fourth limitation of CFT. Then next, okay, this four limitations are there only. ठीक है. So we have finished this third chapter also. हम लोगों ने धीरे धीरे से थर्ड चैप्टर भी क्या किया है, फिनिश किया है. Tomorrow we will start chapter number 4, that is MOT, molecular orbital theory. ठीक है? And tomorrow only after the 20 minutes lecture, I will conduct the online examination based on chapter number 3, that is CFT. That is CFT. ठीक है? Okay. Now, if you have any problem regarding limitations, Nephelauxetic series, and application of CFT to the octahedral complexes, you can ask me. I will give you 5 minutes for that. And after that, you can write your attendance. After that, you can write your attendance. Okay? So, if you have any problem, any doubt, you can ask me. No problem. नो प्रॉब्लम टू एनीबॉडी, किसी को भी कुछ भी प्रॉब्लम नहीं है. Okay, that means you have understood the whole lecture. ठीक है? Supriya is saying no doubt sir. Okay, चलो no problem. So study for today's examination. No problem, thank you sir. Vishwajit is also saying no problem. Okay, if no problem then it's good. I am very happy कि आप लोगों को लेक्चर पूरा समझ में आता है. That is good for me and you people also. ठीक है? Chetan was asking about the result के बारे में I don't know because this is your internal examination. जब तक मुझे कॉलेज या डिपार्टमेंटल हेड कुछ ऑर्डर नहीं देते तब तक आई विल नॉट शो यू द रिजल्ट. Maybe I can show you result, but not after the exam. We will discuss what to do. We will discuss कि result declare करना है नहीं करना है. Then what happens? ठीक है? देखते हैं क्या होता है. And then maybe I will show you the marks also. After 3 to 4 internal examination syllabus, all 3 chapters. Chapter number 1, that is introduction to coordination chemistry. Chapter number 2, valence bond theory. Chapter number 3 is CFT. Mansi is asking sir any question back. जो मैंने question फर्स्ट टेस्ट में सेकंड टेस्ट में पूछे ना उसमें से ही आने वाले, और थर्ड टेस्ट में जो कर लेने वाले हो ना उसमें से ही क्वेश्चन आने वाले. डोंट वरी अबाउट दैट. ठीक है? ओनली 5 क्वेश्चंस है मेरे और 5 क्वेश्चंस मैडम के, तो कुछ नहीं है उसमें. Okay, now any doubt? Any problem? Mansi is saying thank you sir. Okay, no problem. So shall I stop here now? I have activated the link for your attendance. Please write present over there if you have attended the online lecture. Then only write the present. ठीक है? Otherwise don't write present. So shall I stop here now? बोलो. Okay, chalo. Bye bye. Take care. Have a good day.